So let's start with the 31st question. Now, if you see this capacitor, now this is connected to the ends with an ideal wire, which basically means that the potential difference across this capacitor becomes zero. So this capacitor does not carry any charge, which means that this capacitor is of no use. Now let's take this point as the A point and this point as the B point. So we draw the equivalent circuit of the capacitor like this. Because this capacitor is of no use. Now there are two capacitors in parallel, which basically means the equivalent capacity is 2C. So the first option is the correct option. Let's come to the 32nd question. The spring is stressed by 5 centimeter by a force of 10 newtons. The time period of the oscillations when a mass of 2 kg is suspended by it is. Now we know that force on a spring is equals to K times X, the elongation. Now this value is 10 newtons and the elongation is 5 centimeters, which basically means 0.05. So this makes the value of K as 200 Newton per meters. Now, what is the time period of oscillation of a spring block system? Let's take a spring block system over here. The oscillations take place and the time period becomes 2 pi under root m by k. So this value becomes 2 pi under root of 2 divided by 200, which means 2 pi by 10, which means pi by 5. So this value becomes 0.628 seconds. So the correct option for this question is the third option. All right. Now let's come to the 33rd question. A small block slides down a smooth inclined plane starting from rest. So starting from rest implies that u is equal to 0. Now Sn be the distance traveled by the block in t is equals to n minus 1 to t is equals to n seconds. So Sn is the displacement in the nth second. Now the formula for displacement in the nth seconds is u plus half a into 2n minus 1. Now, since u is equal to 0, this value is equal to 0. The value of Sn becomes half a 2n minus 1. And the value of Sn plus 1, which is being asked in the question, becomes 2 half a 2n plus 1 minus 1, which basically means half a 2n plus 1. Now, this is the first equation. If we consider this, this becomes the first equation, and this becomes second equation. And let's divide these two. So Sn divided by Sn plus 1, which means the equation number 1 divided by equation number 2 becomes equal to 2n minus 1 divided by 2n plus 1. So the correct option for this question is 2n minus 1 divided by 2n plus 1, which basically means the first option. Let's come to the 34th question. The escape velocity for the Earth surface is v. The escape velocity for the surface of another planet having a radius 4 times that of Earth and same mass density is. Now we know that the escape velocity formula is under root 2 gm by r. Now since mass is not given and density is given, we can replace mass by density times volume, rho times, since planet is considered as a sphere, we can write 4 by 3 pi r cube. So this becomes r square times this value. This becomes r and some constant c. So we can make out from this expression that v is proportional to the radius. Now, if the radius becomes 4 times and everything else remains the same, obviously the escape velocity becomes 4 times. So the correct option is the third option. Let's come to the 35th question. Now, E and G respectively denote energy and gravitational constant. Then E by G has the dimension of. Now, we know this formula, F is equals to G m1 m2 divided by r square. Now, what we do is to bring F and R together, and F and R makes force time length, which is the dimension for the energy, and this becomes dimension of G, dimension of m square, and dimension of L. So the value of dimension of E to the dimension of G is m square L minus 1. So from here we get the correct option is it has to be m square L minus 1. This is not minus 2, this is minus 1. So this is the fourth option. All right. Now, question number 36. A uniform rod of length 200 centimeters and 500 gram is balanced on a wedge placed at 40 centimeter mark. A mass of 2 kg is suspended from the rod at 20 centimeter and another unknown mass m is suspended from the rod at 160 centimeters as shown in the figure. From the find the value of m such that the rod is in equilibrium. All right, so let us draw this diagram. This is the fulcrum, or rather the point of the hinge. This is located at 40 centimeters. Now there are certain forces acting on this. The first force is equal to 2 kg, that is 2g, which is located at a distance of 20 centimeters from here. All right. Now the second force, that is equal to the weight of the bar, that is 500 grams, that is 0.5 g, which is located at 100 centimeters the center, or rather it is located at 60 centimeter from the hinge. Now another mass is located at 160 centimeter, that is 120 centimeter from the fulcrum, right over here, and this value is equal to mg. Now the clockwise torque is same as the anti-clockwise torque about the hinge. So what we can write is 2g multiplied by 20, which is the anti-clockwise torque about the hinge. That is same as the clockwise torque about the hinge, which is 0.5 g times 60 plus mg times 120. Now once we solve this, we will get the value of m as 1 by 12 kgs. All right. So this third option is the correct option. All right. Let's come to the 37th question. A particle moving in a circle of radius r with a uniform speed takes a time t to complete one revolution. Now this certainly means that the speed v and 2 pi r divided by v is equal to t. So the value of v becomes 2 pi r divided by t. This is our first equation. Now, if the particle were projected with the same speed at an angle theta with the horizontal, so it is talking about a projectile motion. Then the maximum height attained is 4r. Now this value is h. So we know that the value of h, which is given as 4r in the question, is actually equal to v square sin square theta by 2g. So from here we can write 4r is equal to 4 pi square r square at t square sin square theta divided by 2g. So from here we can write sin square theta is equals to 2g t square by pi square r, and the value of theta becomes sine inverse under root 2gt square by pi square r, which means that the third option is the correct option. All right, let's come to the 38th question. A series LCR circuit containing 5 Henry inductor, 80 microfarad capacitor and 40 ohm resistor is connected to 230 volt variable frequency AC source. Now the frequency is variable. The angular frequencies of the source at which the power transfer to the circuit is half the power at the resonant angular frequency are likely to be. Now, what we can say, what we can analyze is that power is proportional to current square. Now, if power is 1 by 2, then current is obviously 1 by root 2 times that in the resonant circuit. So, I dash is equals to 1 by root 2 times I in resonance situation, which basically means V naught divided by under root of impedance, that is impedance R square plus omega L minus 1 by omega C whole square is equals to 1 by root 2 times V naught divided by R, which is the case of the resonance. All right. Now, once we solve this, we are going to get 2r square is equals to r square omega L minus 1 by omega C whole square. So the value of r becomes equal to all right. Now, once we solve this quadratic equation, we are going to get option 46 radians per second and 54 radians per second. So this option is not 40, this is 46 radians per second and 54 radians per second as the correct option. Once we solve this quadratic equation, all right, let's come to the 39th question. For the given circuit, the input digital signals are applied at the terminals A, B, and C. What would be the output at the terminal Y? Now, this is A and this is B. This certainly becomes A dot B. And this is B and this is C and is passing through a NAND gate. This becomes A dot B bar. And now what is the output Y? This is AB plus AB bar. All right. Now, if we analyze this for this circuit, the value of A and B is given as 0 and 0, and C value is given as 1 in the first case. Now, if you put this value, AB becomes 0 and AB bar becomes 1. So this is always equal to 1. Now, AB and AB bar is certainly equal to 1, because whatever the value of AB is, let's say if AB is 0, then AB bar is certainly equal to 1. And if AB bar is equal to 1, then AB is certainly be 0. And if we take an OR over here, we will get always equal to 1. So the correct option is the third option. All right. Now let's come to the 40th question. A step down transformer connected to an AC main supply of 220 volts is made to operate at 100 is made to operate at 11 volts. So this is 11 volts and the power output is 44 watt. So considering an ideal transformer, the power input is also 44 watt. Now the primary voltage is 220 volts. You have to find the primary current. So obviously input power is equals to primary voltage multiplied by primary current. So this is 44 and this is 220. So the value of IP is 4 by 20, which means 0.2 amperes. The correct option is fourth option. All right.